This is for Year 11 methods. It comes out of the Chapter 1 review. It's question 12. And what's important in here is true for all values of x. What does that actually mean? True for all values of x. Well, x squared equals x plus 1. Sorry, x plus 2. Are they equal? Well, most students would say no. If you take x and plus 2 to it, isn't the same as squaring x. For example, when x equals 0, the left-hand side equals 0, but the right-hand side equals 2, and therefore they're not equal. If I was to do a graph of the left-hand side, I'd get a parabola, and a graph of the right-hand side, I'd get a straight line, and they're obviously not the same. However, when x equals 2, the left-hand side is 4, and the right-hand side is 4. So, sometimes they're equal, and sometimes they're not. But in this particular case, we've got to have true for all values of x. That is, they're identically the same. So if I look at the first expression and the second expression, if I was to take a common factor out of, well, 4x and 2x are not the same, therefore they're not equal for all values. 7x and minus 2, not equal for all values. In B's case, if I expand the left-hand side, 5x plus 15, that is equal to 5x plus 15. So B is true for all values of x because they're identically the same. 3x and minus x, well, they're not the same. 2x and 2x are the same, but plus 4 and plus 6 will give me different values for the left and the right. So B is the case because the left-hand side exactly equals the right-hand side, and it's for every possible value of x. Remembering that there can be some situations, for example, 3x plus 1 equals 5x minus 3. They're equal when x equals 2. When x equals 2, that gives 7, and that also gives 7. So for x equals 2, they're equal, but for all the values of x, they're not.